Good morning, and welcome to today's live webinar for the release of the nation's report card, Science 2011 at Grade 8. I'm Cornelia Orr, Executive Director of the National Assessment Governing Board and moderator for today's event. The Governing Board is an independent bipartisan board that sets policy for the National Assessment of Educational Progress, also called NAEP, or the nation's report card. As you know, report card releases shed light on very important topics and trends in our education system, and science is no exception. Today's event is sure to provide valuable insights as we compare results from the 2009 and 2011 science assessments at Grade 8. As we explore data from physical science, life science, and earth and space science, and as we review background questions that provide helpful context about students' academic performance. Before we begin today, I'll briefly run through the order of our speakers, and then our webinar producer will review the meeting logistics. Our agenda today includes 3 speakers. First, we will hear from Jack Buckley, Commissioner of the National Center for Education Statistics, who will present the NAEP Science 2011 Grade 8 results. Then Hector Ibarra, a National Assessment Governing Board member and award-winning middle school science teacher, will discuss creating a learning environment that challenges students and boosts achievement, as well as the benefits of an inquiry-based teaching approach. His own inquiry-based teaching methods have been recognized by the Milken Family Foundation. And finally, Jennifer Harper Taylor, President of the Siemens Foundation, will address the need to take a comprehensive approach to advancing STEM education and touch on popular Siemens initiatives designed to train and encourage participation in team participation in science study. Following Jennifer's remarks, we will have a brief question and answer session with all attendees and speakers. Before we begin our presentation, Rick, our webinar producer, will address logistics for using the WebEx system. Rick?
Thank you, Cornelia. Our speakers will address questions during a Q&A session later in the event, but attendees are welcome to submit their questions throughout the entire presentation. Simply type your question into the Q&A window on the lower right side of your WebEx screen and submit your question to all panelists. Please be sure to include your name and organization with all your questions. If you have technical issues, please refer to your confirmation email or call 866-229-3239. Thank you. Back to you, Cornelia.
Thank you, Rick. Before we begin, I want to let people know that the Governing Board added NAEP Science 2011 to the usual 4-year testing cycle so that comparisons in 2011 could be made with the performance of U.S. students on the latest Trends in International Mathematics and Science Study, or TIMSS. Results of the 2011 TIMSS assessment will be compared with NAEP Science results and mathematics results in an upcoming study slated for release much later this year. The study will also include the results allowing states to see and the public to see student performance in both subjects for states in relation to other nations. I also want to emphasize that this is a voluntary state assessment and that all 50 states and the District of Columbia participated in 2011. This was a first-time occurrence for a voluntary assessment, and previously it had been in the neighborhood of 40 to 45 states who volunteered to participate. So I want to, first of all, thank all of the states who did participate in that. Now it's my pleasure to introduce our first speaker. Dr. Jack Buckley is Commissioner of the National Center for Education Statistics, on leave from his position as a Professor of Applied Statistics at NYU. He is well known for his research on school choice, particularly related to charter schools, and on statistical methods for public policy. Jack spent 5 years in the U.S. Navy as a surface warfare officer and nuclear reactor engineer, and he also worked in the intelligence community as an analytic methodologist. Jack, thanks for being here.
Well, thanks very much, Cornelia. And good morning. I'm very happy to be here to share with you the results of the NAEP 2011 Science Assessment that we're releasing today in this Science Report Card. As Dr. Orr mentioned, we assessed in 2011 in science only students at the 8th grade level, with a sample size of approximately 122,000 students. We are fortunate in that we have results available not only for the nation, but also, as Dr. Orr mentioned, that students from all 50 states, as well as the District of Columbia and the Department of Defense school system participated in this assessment, which actually marks the first time that all 50 states in the district agreed to participate in a voluntary science assessment. Also, as Dr. Orr mentioned, the governing board added grade 8 science to the assessment schedule in 2011, specifically to create an opportunity to study the relationship between U.S. results in science on the NAEP, but also how the U.S. stacks up to other countries on the Trends in International Math and Science Assessment, or study rather, the TIMSS. And we will be releasing results from that analysis in December. As always, on this assessment, as in all other NAEP assessments, we report results in two ways: average scale scores, in this case on a 0 to 300 point scale, and as percentages of students attaining at or above the various achievement levels which are set by the National Assessment Governing Board. These achievement levels, the basic, proficient, and advanced, tell us what students should know and be able to do. Also, in this report, we're able to make comparisons back to 2009. Unfortunately, we can't make direct comparisons back to prior years because of changes to the content framework and also the achievement cut scores for the 2009 science assessment. The 8th grade science assessment covers science content in three areas: the physical, life, and earth and space sciences, with content distributed approximately 30% each to the physical and life sciences and 40% to the earth and space sciences. So looking at the results overall, on average, we see that 8th graders in science in 2011 increased their score 2 scale score points compared to the results in 2009. When we also turn not just to look at the average, but look across the percentile distribution, we can see that students at varying ability levels also increased their scores compared to 2009. So students at the 10th, 25th, and the 50th and the 75th percentiles all showed improvement on average, although students at the top, the 90th percentile, statistically we see no improvement there. As you'd expect from those scale score results, we see a similar pattern in the percentages of students at or above achievement levels. We see an increase between 2009 to 2011 in the percentage of students at or above basic level, which is the bottom of those bars, from 63% to 65%, and an increase, statistically significant increase of 2 percentage points from 30% to 32% in students at or above proficient level. Although recall, since there was no gain at the 90th percentile, here we see, again, no change in the 2% of students at the advanced level in both years. In 2011 was the first time that in NAEP we were able to disaggregate the race and ethnic categories of students in accordance with the directive from OMB, the Office of Management and Budget, in line with the census of 2000. What this means in terms of NAEP is actually for the first time in 2011 for our reading and mathematics and now for science results, we're able to disaggregate Asian students from Native Hawaiians and other Pacific Islanders. So you can see here the average Asian student scored a 161, which is similar to the average white student score of 163 on the scale, both groups outscoring Black and Hispanic students. But you can see the distinction or the difference between Asian students and Native Hawaiians or other Pacific Islanders, which we were not able to report on previously. We're also, for the first time, able to provide results disaggregated for students of 2 or more races. And I should just point out as well, to the left of the bars, the number there labeled percentage of students shows us for the 8th grade population that we assess what percentage of students were in each of those categories. There's good news in general for achievement gaps in science in these results. What we see here is that the gap of scale score points between white and black students actually narrowed between 2009 and 2011 for 8th grade science, dropping from 36 points to 35. And also importantly, the way that the gap changed or closed was by both groups increasing their average scores, but by black students increasing their scores slightly more than white students. Similar pattern, although a more dramatic closing of the gap for the white Hispanic score gap, which closed from 30% or scale score points to 27, again with both groups improving on average. In the 2011 8th grade science assessment, we see evidence of a persistent gender gap, which we have noticed in prior assessments between boys and girls, with male students continuing to outscore female students in science on average. Also, something we see across all of our other NAEP assessments, there continues to be a gap between students of varying income levels. As always in NAEP, we measure the socioeconomic status of the families that students come from using eligibility for the National School Lunch Program as a proxy, so measuring whether or not they're eligible for free or reduced price lunch. And what we see here is that students from families who are eligible for free or reduced price lunch were outscored by students from families that were not eligible. The top bar is showing the difference in 2009, and the blue bars on the bottom showing the difference in 2011. There are some slight changes there, but it's really the same pattern that we've seen before and that we see across all our other assessments. Similarly, there is a persistent gap between students attending private, in this case private including Catholic schools, the middle set of bars, or just Catholic schools, and students attending public schools, which are shown on the top bar. Although, of course, recall that this is not necessarily evidence of improved instruction in these schools as much as there could be issues of selection in terms of what students attend what type of school. So when we turn from the national results to the state results, again, we see in general a pattern of good news. Where there were any significant differences looking from 2011 back to 2009, there were improvements. So we see, in fact, 16 states scored higher in 2011 for 8th grade science than they did in 2009. And then comparing just within 2011, if we compare states to the national average, we see that students in 29 states and jurisdictions actually outscored the nation in 2009. There were a handful of students that were not, states rather, that were not significantly different, and then the remainder, of course, scored lower than the national average. As always in NAEP, in addition to the assessment items, we collect data on a wide variety of background questions, additional factors about the students, about their teachers, their backgrounds, educational experiences. This is an example where we look at the average scale score for students of, depending on how often they reported doing hands-on projects in class. Actually, the teachers were reporting the instruction in this case. So what you can see here is a pattern where 2% of the students reported never or hardly ever doing hands-on projects in science. It had the lowest average scale score on NAEP, where at the top, 16% who were reporting performing hands-on projects in science instruction every day or almost every day had the highest average scale score. Although, again, I would caution you, this is a correlation, but there's not evidence that, for example, performing more hands-on projects necessarily leads to improved achievement, because there could be other factors correlated with both likelihood of doing hands-on projects in science as well as achievement. Similarly, one of the background questions that we asked the students was how often or whether or not they do science-related activities outside of school, so things that are not directly for schoolwork. So in this case, the scale is just asking how do they agree with that statement, and you can see that students who more strongly agree with the statement that they do science-related activities outside of schoolwork, on average, also score higher on the assessment. So now we turn to some sample items from the assessment. This first one from the Earth and Space Sciences section. And what we ask here is a diagram that shows a collision of two tectonic plates in Asia. And we ask students to select the answer that identified the most likely results of the collision. 72% selected the correct response, C, that the collision caused the Himalayas to increase in height each year. For an example of a physical science item, here we ask students to identify the atoms and their proportions in a molecule of water. And we see here that 54% chose the correct answer, again C, that two atoms of hydrogen and one of oxygen combine to make a molecule of water. It's interesting to note here that a large number, 34% of students, chose the incorrect response option B, possibly because they read the item across as looking like H2O as 1 hydrogen, 2 oxygen. And finally, here's a somewhat more complex example of a what we call an extended constructed response item from the life science section of the assessment. So here, students were given the results of an experiment involving the immature forms of mosquitoes, the larva and the pupa. And these correspond, of course, to the caterpillar and chrysalis stages of a butterfly, except that the results are not as pretty. So both the larva and the pupa live in water at the surface, and both are capable of diving below the surface to avoid danger. This extended constructed response question described to students an experiment involving a larva and a pupa, each placed in a jar of water 50 centimeters high. The experimenters then tapped on the glass and measured both the depth to which the larva and pupa descended and the time they spent below the surface. The experiment was repeated 5 times, and the results averaged. Students taking the assessment were then given a chart summarizing the findings as shown here. So for the larva, the average depth reached was 22 centimeters, while the average length of time spent underwater was 90 seconds. For the pupa, the average depth was 38 centimeters, and the average time was 120 seconds. So students were then given a list of 6 statements and told to select all the statements that were true. Statement D, the pupa dives deeper than the larva, and statement E, the pupa stays underwater longer than the larva, were true statements. But not only did we want to see if they could interpret the results from the experiment, we then actually asked if they could explain why they selected the statements that they chose and support that with data from the table. So these answers could be scored as complete, essential, partial, or unsatisfactory or incorrect. Complete responses selected only statements D and E and had to refer to the data in the table to correctly explain both selections. Essential responses selected only the correct statements D and E, but used data from the table to correctly explain only one of the selections. Partial responses might have mixed that up. Maybe they got D and not E. Maybe they could only give little or no explanation for one of them, or might have included something incorrect from the table. And of course, an incomplete response did not select either of the correct D or E, and also could not justify their answer. So here's an example of the student's response who was graded as complete. So this student was assessed to have complete understanding of the behavior of mosquito larvae and pupa. And as you can see from their answer, the student stated, I picked that the pupa dives deeper than the larva because the pupa dives 38 centimeters and the larva dives 22. I also picked the pupa stays underwater longer than the larva because the pupa stays underwater 120 seconds and the larva stays underwater 90 seconds. So clearly they're demonstrating they were able to read the data from the previous slide. Another student receiving a complete rating gave this answer, the second one, that the pupa stays underwater longer than the larva does by 40 seconds. The pupa also dives deeper than the larva by 16 centimeters. And looking over the response distribution, we see that 15% of students gave a complete answer, while 2% an essential answer, and 32% gave a partial. So the 2011 Science Report Card provides all this information and much more. In addition, the initial release website gives extensive information on the performance of students, access to released assessment questions through our Question Center, and as always, the NAEP Data Explorer, our online data analysis tool that lets you look at the background questions and compute analyses on your own. In conclusion, as always, I'd like to offer my sincere thanks to all the students, teachers, and schools who made this possible by participating in the 2011 Science Assessment. Thank you.
Thank you, Jack. Our second speaker, Dr. Hector Ibarra, is a nationally lauded for his expertise in science. Before accepting his current position as a middle school science teacher at the Belin Blanc International Center in Talent Development at the University of Iowa, Hector taught general and earth science for 30 years at West Branch Middle School in Iowa. Among his many awards is the prestigious Milken National Educator Award. Thank you for your time today, Hector.
Thank you, Cornelia. As a middle school science teacher with 36 years experience, I quickly looked beyond the scores when reading the NAEP Science Report Card. It's good to see an overall increase from 2009 to 2011 among our 8th graders, with the percentages of students scoring at or above the basic and proficient achievement levels increasing over this 2-year period. But it is important to go beyond the trend results and examine factors that influence improved science achievement. A large part of this picture is how teachers are teaching and how students are learning. How do we use the information from the NAEP Science Report? Please refer to the next 4 slides. First, we see how important it is for students to do hands-on activities. As part of the 2011 NAEP Science Assessment, teachers were asked how often their students did hands-on projects. The NAEP data reported that students whose teachers use hands-on activities in the classroom do better on the NAEP than students whose teachers don't use activities. Students whose teachers answered never or hardly ever had an average scale score of 140, while those who said they did 1 or 2 activities per week had an average scale score that was 14 points higher. Second, being involved in science-related activities outside of the school is often taken for granted, but it does make a difference. The report again sheds light on this. 8th graders who took the assessment were asked to indicate the extent to which they disagreed or agreed with the statement, "I do science-related activities that are not for schoolwork." 25% of the students answered strongly disagree, and the group's average score was 146. At the other end of the spectrum, only 4% of the students strongly agreed, but their average scale score was 162. On the next slide, third, it is important to have students work together on projects where they discuss ideas and work as a team to find solutions to the problem. Teachers who reported their students work together on science projects 1 or 2 times per week scored higher than students whose teachers reported their students never worked together. 4% of the teachers reported their students never or hardly ever worked together and had an average scale score of 147. 47% of the teachers reported their students worked together 1 or 2 times per week. Their scale score was 153. Again, it is no surprise to me that students who do hands-on activities, work together in science class, and do science projects outside of class all scored higher on NAEP than students who didn't. Fourth, and you can see on this slide, writing in science is important. Constructed response questions required students to explain their answers. Constructed response questions challenge students to use critical thinking skills, scientific inquiry, and problem-solving skills in developing their answers. Students organize their thoughts and findings in written form. This increases their understanding of science and their skills in writing. 15% of the students were scored as having complete responses, while 50% were scored as having unsatisfactory or incomplete responses. I believe if teachers require students to write more often, there would be an improvement in student performance on NAEP constructed response questions. From my perspective as a teacher, an important aspect of the data is how students are engaged in doing hands-on activities in class. There are many ways students are exposed to science. Some of them are more effective than others. The question to ask is, are we creating a learning environment that truly challenges the student's skills and boosts achievement? The National Science Education Standards were developed by the National Research Council in 1996. Inquiry was a major component of the standards. There are many forms of inquiry, from guided to open inquiry teaching approaches. Students are more in charge of their learning as they find solutions to their questions. However, doing hands-on activities in the science classroom doesn't necessarily mean the activity is inquiry-based. Many activities done in science classrooms tend to be cookbook type of experiments where students learn to follow directions and are told what to do. In my classroom, I started inquiry-based projects in the late 1980s, well before the national standards were developed. I revised the cookbook experiments to include questions to help guide the students' learning process. With inquiry-driven activities, students are provided opportunities to expand their learning, to solve problems, and to use their creativity to arrive at solutions. An inquiry-based teaching approach dissuades mere memorization and requires comprehension of what it takes to arrive at possible solutions. The series circuit experiment slide that you see is an example of a hands-on inquiry activity I use with my 6th grade class. This is a common science experiment for studying series circuits. I revised the experiments to present students with a problem statement, general instructions, and some of the questions that you see that are answered only by experimenting to come to an understanding about series circuits. A commitment to inquiry in the classroom represents a profound shift from the comfortable methods some teachers use. Inquiry teaching approaches has the students, not the teachers, in charge of their learning. Students are asking questions, and teachers are redirecting the questions with other questions. Students who win local and national science competitions are critical thinkers who have learned how to solve problems on their own. We must ask ourselves, are we ready to fundamentally change what we do and how we teach in classrooms and how prospective teachers are taught in university teaching programs? Successful science programs are often a combination of things, from partnering with different entities and organizations that bring in models or offer free lab time for students to having students take the lead on experiments and determine possible solutions to the issues that are being investigated. However, it's not just about having equipment and resources. It is more about how we think about teaching and learning. The most important idea students can learn in class is to be passionate about the process of learning. Science is such an important part of our everyday life. Educators would be wise to provide the best environment we can make to make science come alive for all students. Thank you.
Thank you, Hector. Our final speaker today leads one of the nation's preeminent nonprofit organizations dedicated to science, technology, engineering, and mathematics education. As president of the Siemens Foundation, Jennifer Harper Taylor has introduced tens of thousands of young people to opportunities in STEM, and she is active on a number of fronts to close the minority achievement gap in STEM education. We look forward to your insights, Jennifer.
Good morning, and thank you, Cornelia. Engaging students nationwide in science, technology, engineering, and mathematics has been my focus with my work at Siemens for more than a decade. So I'm honored to have been invited to comment on the 2011 National Assessment of Educational Programs in Science at Grade 8. Science, technology, engineering, and mathematics, STEM, education is vital to our students and our nation's future. The jobs that are growing the fastest here and around the world are by and large in STEM fields. Over the past decade, the number of STEM job openings grew 3 times faster than total non-STEM jobs. Moreover, our ability to meet the global challenges of the 21st century depends on STEM education. We need to train the next generation of inventors, doctors, and engineers, and that requires a serious commitment to improving STEM education. Looking at the results of the latest national report card, I was pleased to see that 8th grade performance in science has improved over the past 2 years, with the average science score 2 points higher in 2011 than in 2009. This may not represent a huge leap forward, but it is definitely a step in the right direction. I was also glad to see the score gaps between white and black students and between white and Hispanic students narrow. Closing the minority achievement gaps in STEM is hugely important to our nation's long-term ability to stay competitive. Although public school students did not score 2 points higher, although public school students did score 2 points higher in 2011 than in 2009, I was disappointed to see no significant change in the gap between private schools and public school student performance over the last 2 years. But this only underscores that the need to take a comprehensive approach to advancing STEM education with a national commitment to flexibility and innovation. I was also not surprised to see that students who do hands-on projects in class are more frequently scored higher than students who do hands-on projects less frequently. Engaging students in hands-on science is the cornerstone of our work at the Siemens Foundation. Our Siemens Science Day program is a public-private partnership that brings hands-on student science learning and teacher professional development into public schools across the nation, and they're aligned with national teaching standards. We launched this program in 2005 and have reached over 30,000 students nationwide to date. I was glad to see about 2/3 of the students work together on science projects at least weekly. In the real world, science is almost always done in teams, and it's important that we encourage teamwork in science. Our Siemens We Can Change the World Challenge was designed specifically for students to compete in teams. This sustainability challenge empowers students at the elementary, middle school, and high school levels to create solutions to today's environmental problems. students have come up with some incredibly impactful ideas for this challenge that have been implemented by schools, communities, and organizations nationwide. Making science relevant to students' real lives and concerns is an important goal for us at the Siemens Foundation. Our Siemens competition in math, science, and technology also encourages and rewards team participation. This national competition gives high school students the opportunity to perform original, hands-on research and present their work to some of the leading scientists and educators across the country. We believe at the Siemens Foundation that challenge-based learning is essential to getting young people excited about science. I was also not surprised to see that students who report doing science-related activities that are not schoolwork, or not for schoolwork, score higher than their peers. Students need to engage in science throughout their daily lives and not just in the classroom or a part of homework. Many of the students who have completed successful competition projects for the Siemens competition in math, science, and technology have told us about their parents' help, mentors, and people in the community that have helped make science a part of their everyday lives at a very early age. We need more parents and community leaders and mentors to encourage their children's interest in science inside and outside of the home. I'm pleased to see the positive momentum in 8th grade performance in science, but we really still have a long way to go. We need to create a culture that celebrates science at all levels of our society. We need to encourage students to do more hands-on learning, challenge students to do original research, and encourage our students to work in teams. We need to do a better job at making STEM topics relatable to students and their everyday lives. And we need to do a better job of recognizing and rewarding the educators and students who are successful in STEM and make sure that their work does not go unnoticed. Again, I'd like to thank you for the opportunity to comment today on behalf of the Siemens Foundation, and now I'll turn it back over to Cornelia.
Thank you so much, Jennifer. Now we will respond to attendee questions during a brief question and answer session. Please submit your questions online, and our facilitator, Amy Buckley, will direct the questions to the appropriate speaker. Now I'll turn the session over to Amy.
Thank you so much, Cornelia. For those of you who have questions about today's report card results, please submit them now. As Rick mentioned, we ask that you direct your questions to all panelists, and please remember to include your name and organization when typing in your question. As a reminder, we have Dr. Cornelia Orr, Dr. Jack Buckley, Dr. Hector Ibarra, Jennifer Harper-Taylor, available, who you heard from today, as well as Dr. Peggy Carr, Associate Commissioner with NCS. All are available to answer your questions. Finally, we will be mindful of everyone's time, so if we are not able to respond to your question during the event, please know that we will via email. Thank you so much for your interest in today's webinar. Our first question comes from Mark McCaffrey, a Programs and Policy Director with the National Center for Science Education. Mark asks, do you have a sense of whether and how climate change and other human impacts on the Earth's environment are covered in 8th grade science overall? These topics are often missing or not well covered in existing state standards. Cornelia, could you address that, please?
I'll be glad to. This topic is covered at all 3 grades, 4, 8, and 12. Of course, we're talking about grade 8 today. The NAEP Science Framework, which is available on our website, covers these topics in the Earth and Space Sciences content area. At grade 8, the specific objective describes how human activities have changed the Earth's land, ocean, and atmosphere, often in negative ways. And you can find these contents in the other grade levels as well.
Great, thank you so much. Our second question comes from William Bertrand, a Technology Education Advisor with the Pennsylvania Department of Education's Bureau of Teaching and Learning. He comments, I understand that there was a technological design component to the test of 10%. Why is this not being reported on, like physical sciences, life science, and earth and space sciences? Jack, could you address that?
Sure. It's a great question. So as I mentioned, we've got 3 science content areas in the assessment of physical, life, and earth and space sciences. But cutting across those content areas are also 4 science practices. In this case, identifying science principles, which focuses on students' ability to recognize, recall, define, relate, and represent basic science principles in each of the 3 content areas. Using science principles, using scientific inquiry, which looks more at designing, critiquing, evaluating scientific investigations and experiments, and identifying patterns in data. And then using technological design, which focuses on the systematic process of applying scientific knowledge and skills to propose or critique solutions to real-world problems. And so technological design actually is present across items in all 3 of the content areas. About 10% of the assessment was designed to assess technological design understanding. But we don't report out on the 4 science practices. We only report out on the subscale content areas. However, if you go online and look at the questions tool, the NAEP questions tool on our website, you can actually filter or sort out publicly released items by science practices. And so you can see examples of items that directly were designed to assess technological design.
Great. Thank you so much. Our next question comes from Susan Dish, no affiliation that was provided, and she would like to know, is there any data on specific science curricula used in the classrooms of those tested? Jack, could you respond?
Well, yes, in the sense that all the NAEP assessments include the background questionnaire survey items that I discussed, which are given to students, teachers, and school administrators. And so a selection of these results, again, is available both in the report, and we showed some here today, and also on the Nation's Report Card website. So for instance, on the website, you can find information about the amount of time students spend working collaboratively on science activities, as well as the amount of time they spend doing hands-on activities in school. We've got charts and tables that show the percentages and average scores of students in the nation and the states that participated in these various curricular activities and other contextual factors. On the other hand, if you meant science curricula more narrowly in terms of specific commercial curricula, then no, then actually NAEP is not designed to assess or evaluate specific commercial curricula.
Great, thank you. Our next question is from Scott Foreman. He is president of Allegro Productions. He asks, how can we get more corporations involved with STEM education in their local communities, either through mentoring and scholarship programs or the underwriting of curriculum enhancement materials that are provided to teachers free of cost? Jennifer, could you start us off with that one regarding how corporations can assist at the local level with STEM?
Absolutely. I think there are many initiatives that currently exist for local outreach to occur with corporations and communities. I think first and foremost you need to identify who the corporation is in your community that has a technological opportunity to either work with students and or engage and show students some of the things that they're working on in their particular corporation. But I think that it's also important to look for national programs that exist within corporations where they're looking to do local outreach. An example is for the Siemens Corporation, and Siemens Foundation has a program called our Siemens Science Days, and we actually use this as a local initiative nationwide, and our employees who have varied backgrounds in the areas of STEM go out and spend time with students, but they also teach them lessons that are aligned with national teaching standards for those grade levels. So it's an enhancement to what the educators are doing in the classroom, but it's also an opportunity for the kids to have a hands-on learning experience. There are also many scholarship programs that exist in corporations because they see, of course, these students as a pipeline to be able to come in and provide innovative opportunities for the corporations to grow in the future. And they're also very interested in making sure that educators have an opportunity to learn more and engage students more in the area of STEM. So programs like the Siemens STEM Academy exist so that teachers have an opportunity to have some hands-on educational professional development experiences that will ultimately touch many students in the future.
Thank you so much, Jennifer. We actually received several questions from people, so I'm going to consolidate them all, if you'll allow me to, regarding the Next Generation Science Standards and how it may or may not be aligned with NAEP, as well as how that will be rolled out in the Common Core through science and the time frame for that. Sue Schroeder, a volunteer with Oshkosh School District, stated it as, I understand that Common Core standard testing conducted by all states is scheduled for spring of 2015 for math and reading, but not science. With the adoption of the next generation science, what is the time frame and rollout of science, and what's the connection or alignment with NAEP? Cornelia, can you start us with that one?
Well, I'll certainly tell you everything I know, which isn't much. So it shouldn't take very long. But I know that there are science standards currently under development now. So I know you're accurate in your statement that science will not be rolled out when reading and math are rolled out. It's too early to know exactly how much like NAEP the assessments will be, because we are just beginning to see some of the proposed assessments and item specifications that are being developed in the consortia. We do know, however, that they relied heavily and reviewed the framework for reading and math in the development of the language arts and the mathematics Common Core standards, and I believe the same is true for science. So I think our framework serves as a good model for them to use for the development of the science standards, because ours were just most recently revised for the 2009 assessment. So ours have been recently updated, and I believe take us a little bit further into how to better assess science.
I just quickly jump in a little bit on the timeline. I think the key here, of course, is that the Common Core state standards exist for reading and math that are not complete for science. But even after the standards for science, should they be developed and adopted by the states, there's a long lead time between getting from those content standards to actually getting an assessment in the field. And so the department has been engaged funding the two Race to the Top assessment consortia, who's only in their second year of work, trying to get us to the stage where we can actually field these assessments in 2014-15. Now, I suspect that it won't take a full 5 years that we're seeing for reading and math in terms of science, if only because a lot of the infrastructure for the next generation of assessment in terms of technology, in terms of the statistical and psychometric models will already have been worked out for reading and math. But it should still take several years, even from the successful adoption of these standards, to actually get us to an assessment in the field. So I wouldn't expect it necessarily anytime soon.
Thank you, Jack. Our next question is from Laura Atkins, a NAEP state coordinator from the state of Tennessee. She would like to know what % of participating students responded to background questions about hands-on projects. Jack or Peggy, could you address that?
Yes, actually, in terms of the response rate for the background questions on hands-on tasks is 100%. We had all the students who took the assessment also responded to those items.
Great, thank you so much. Our next question is from Susan White, no affiliation provided. She would like to know, she notes in the complete response for the pupa and larva that Dr. Buckley presented, the student calculated 120 minus 90 equals 40. So she asks, does that mean that you do not take arithmetic skills into account when scoring science?
Well, so the incorrect arithmetic in this case was not used to penalize the student. So the point here was trying to see whether or not the student could use data to draw an accurate conclusion. That's the science skill under assessment. The ability to make the final correct calculation is important, but it's actually irrelevant to that construct of using data to understand the scientific conclusion.
Great, thank you very much. Our next question, and I apologize, I'll do the best with your name, Aola Fortune. She would like to know, what are some best practices for improving the achievement of African American, Latino, and low-income students in science? Are there strategies beyond what has already been discussed today, such as inquiry-based learning, working in teams, etc.? Hector, could you comment on that from the classroom view, some of the best practices you know for narrowing achievement gaps? And then to follow up, Jennifer, if there's anything that you're seeing in your Siemens programs that has proved effective.
Yes, I can. From my perspective, first I'll just give you a little bit of my background. I was born in Mexico. I didn't learn English till I was in 4th grade. And one of the biggest things I saw that helped me was that teachers were interested. And that's one of the biggest things that I tried to do as a teacher was show a big interest in students, all students. There are many students that are kind of just out there, and lots of people don't speak with them. And so it's really important to make not only eye contact, but actually, with a smile, visit with them, talk to them, present them with ideas, talk to their parents about opportunities that could be present if they just get more involved. So from my perspective, that's the real key, is just showing an interest in the child.
This is Jennifer. The thing that I've seen as I work with the programs for the Siemens Foundation is we make a concerted effort to do outreach that is specific to minorities and underrepresented groups. I think sometimes the digital gap provides a opportunity for these individuals to be missed because they aren't necessarily receiving the information digitally as fast as they could, and the U.S. mail system is also not always the best way if we're still dealing with snail mail in some circumstances at these schools, and reaching out to these educators. So what I found is that if the educator can work with the students, because most students at this point are very technologically savvy, and we work with libraries throughout the country as well from an outreach perspective, but to learn about programs that exist, like programs at Carnegie Mellon University that is specifically geared toward getting students engaged and excited from a minority standpoint in science. So there are many programs that are designed to specifically address those needs, but there are also opportunities throughout the country that have special program components designed to address minority students that may have an interest and may have the aptitude, or some that may not, but they address all levels of students that may have an interest in doing more in the areas of STEM.
Thank you so much, both Hector and Jennifer. Jennifer, while I have you, we have a question from Helena Easter, and she would like to know how she can get her district involved with Siemens and the wonderful opportunities they are providing for students. Could you tell everyone how to get involved with what you spoke of earlier?
Absolutely. We have several programs where educators can receive free professional development resources through our STEM Academy, Siemens STEM Academy. All this information is available on our website, and that's siemens-foundation.org. So there are paid summer opportunities to go to Discovery Education and spend a week-long immersion program working with thought leaders and digital tools. Educators are awarded that for professional development. We work with the Department of Energy's Oak Ridge National Labs and Pacific North Labs to have teachers go there and have an immersion hands-on research experience over the summer. There are many best practice resources that are shared on our STEM Academy site. But more than that, we have so many programs that are designed for student engagement and challenge-based learning from grades K through 12. And all of this information is free. All of the programs are free, provide scholarships in some instances, and, of course, free professional development for the educator. So I encourage everyone, please, go to the website. And there are also links to other programs from other organizations throughout the country, because the goal of the Siemens Foundation is to make an impact. There isn't a competitive scenario with other corporations to try to get the resources to individuals throughout the country. Our hope is that we can make a difference and be able to bridge the gap on STEM educational outreach.
Thank you so much. Our next question comes from Lindsay Lamb with Austin Independent School District, and she wants to know, will there be a tutor release for 2000 NAEP Science? Peggy, can you answer that?
Well, this particular time, 2011, we did not include the tutors in the assessment profile. They will be included in 2015 when we assess science once again, and the comparisons, of course, will be to 2009. So we don't have those data for you this time around.
Great, thank you. Our next question is from William Bertrand, Technology Education Advisor with Pennsylvania Department of Ed, and he asks, what is the progress of the Technology and Engineering Literacy NAEP? Cornelia, could you start us off with that?
Well, I'll begin, and then I'll ask Jack to follow along with that. We are very excited about the Technology and Engineering Literacy Assessment. The board has completed the development of the assessment framework and specifications and has added it to the schedule for the 2014 assessment year. And so we're excited to actually be filling out the STEM component we have math and science, and this will add on to that. So I'll let Jack respond more about, or Peggy, about where we are in the development process.
We are excited about our opportunity to assess TEL, and we are just finishing up with some small group field test opportunities to just perfect our task. We're getting ready to go into the field in January with a fairly large field test to, again, further refine our tasks associated with TEL. And then in 2014, of course, we'll be ready for our operational probe. We call it a probe, however, it will be quite plentiful in terms of the participation of students. We will not have state data, but it is promised to be very rich in terms of what we'll be able to glean from not just scores in terms of percent correct or scores on these particular tasks or scales, but also in terms of process. We'll be able to look at process and how students work through those activities.
It's going to be filled with interactive computer tasks as its primary method of assessment, and I think that's one of the really exciting things and why what Peggy just described about having some interactions with small student tryouts has been very important to us. I will say that I think that this mode of opportunity would be exciting to administer at the state level, and so we are anxiously awaiting the successful implementation of the Common Core assessments that would be online and all states, because I think this infrastructure at the state level has been one of the barriers for NAEP of actually being able to provide access to the interactive computer tasks. While I'm mentioning that, I will just say that one of the advancements in the 2009 framework, which was used for this assessment in 2011, was the inclusion of interactive computer tasks, and there will be a report coming up very shortly next month about the hands-on task components of NAEP in 2009 and the interactive computer tasks. So I hope you're all looking forward to that release.
Thank you. Our next question comes from J.T. Taylor, who is a postdoc researcher in science and special education at the University of Iowa. J.T. would like to know how these findings might influence policy on science and science-related areas as it relates to content standards at the national level. Cornelia and Jack?
Well, I think that question is sort of similar to the content standards for common assessment work, so I won't repeat all that was said there, but I think it is important for schools to know what are the expectations that states have for student learning in science. And so having common standards will be a new opportunity to have this conversation.
I'd just add that these content standards that the governing board developed for 2009 are really quite rigorous. So we mentioned that not only the different subscales or content areas, but also cutting across these other science practices. And if you look at across the sample items, you're going to see a wide range of challenging items. And I think what these results today show us is that even under a very challenging assessment, that our 8th graders at least can show gains, right? So I would say in terms of how this can inform the policy debate on science standards, that I think it provides some credible evidence that those science standards should be rigorous and that we should still expect American students to improve on them.
Thank you very much. Our next question is from David Fardman. He would like to know if there's any data available on how much time students spent in science class per week. And if so, are these correlated at all to the outcomes? Jack?
Yes, actually. So one of our background questionnaire items actually asks teachers in a typical week how much time do they spend on science instruction. When you break this down by percentage of students, the modal response is 61% of the 8th graders spend between 3 and 5 hours of instruction in science a week. About 4%, or actually about 5% in total spend less than that, so very few students spend sort of 3 or fewer hours. About 26% spend between 5 and 7 hours, and about 8% spend 7 or more hours. In terms of that, just tells you some idea about how much time on average do the 8th graders spend in science. The second part of your question is actually really interesting in terms of how does this correlate with outcomes. So as you might expect, when you move from spending less than 1 hour, for example, up to spending between 3 and 5 hours, where most of the students are, we see a statistically significant jump in scale score. So on average, students who spent the least amount of time in science scored about a 146 in the 8th grade assessment. But students who spent between the 3 to 5 hours a week actually scored a 155. What's sort of interesting about that, though, is when you go further, when students spend even more time than 3 to 5 hours in science, what we see in the assessment is actually that the scores on average decline. So students who spend 7 or more hours a week on science on average score about 147, which is closer to actually very similar, statistically identical to the average scale score of the students who spend less than 1 hour. Now, I would say, of course, just as I did when we discussed the other background items, that this is not evidence of causation here. More science instruction past a certain point is not causing these students to underperform. There could be issues of students being assigned to remedial or additional science, so on average they were maybe underperforming, and then they're getting exposure to more science after that. But it was an interesting finding that we saw in the data this year.
Thank you very much. Our next question is from Eric Young with the Colorado Department of Education, who is trying to understand a bit about how teacher professional development was incorporated into the assessment, and if there were any findings on this particular assessment regarding how teacher professional development might have factored into results.
No, I mean, in terms of, we did talk to teachers about their preparation, their background, their teacher training experiences. We don't have a lot of background items that explicitly look at professional development offered. So, for example, we can say things about whether or not they had exposure during their training as a teacher to advanced science courses, both on the arts and sciences content side, but also science education courses. And on average, we see teachers who had either of those, who had preparation in advanced science coursework or science education coursework, have students with average higher scale scores. But in terms of actual professional development when they're in service in this assessment, no, we don't have a lot of background items there.
So I'd like to just add to what Jack has said. Many states have been in the process of changing their teacher certification requirements. It used to be possible, and may still be possible in a large number of states, to get a generic middle school certificate for teaching science or math or any subject for that matter. And many states are revising their procedures to require more specific science teacher preparation. So you might want to investigate that for your state to see where Colorado, that question was from Colorado, right? To see where your state is on what are they requiring of teachers who are teaching middle school science.
Thank you very much. Our next question is from Sue Schroeder, and she's curious about resources available to teachers, ideally free resources, but I'm wondering, Hector, if you could provide her with some information about what you use in the classroom or what you know of that is available to science teachers as well as volunteers.
Interesting question. In my case, one of the things I did is I went through and many different types of information to get information that I could use and to change. But I would imagine that the biggest starting point would be just going to the NSTA resources and looking over some of the textbooks that they have available, like on inquiry, or on best teaching practices. I think that area provides a lot of very good information. Other resources include some of the information from Corwin Press. You get their manual that states what is available. There are many, just a whole array of topics that they discuss that is aimed at professional development in terms of improving their own teaching practices.
Great, thank you. Jennifer, is there anything you'd like to add on resources available to teachers and volunteers in the classroom?
I think, again, I would lead you to the Siemens Foundation website, siemens-foundation.org. There are a lot of resources and links associated there. But I think looking at corporate entities and organizations and foundations, if you go to many of those websites, the ones that have an emphasis on STEM, there are usually links and or resources that will lead you to a lot of free materials for professional development for educators.
Thank you, Jennifer. Our next question is from Lance Jones with AFT. He says, given the change in scoring since 2009, is it at all possible to compare these to prior results? Jack?
Short answer is no, and the longer answer, of course, is that it's not just the change in scoring that matters here. It's really a new content framework. Right? So the governing board spent a lot of time developing a new framework for the 2009 assessment that we use here, in making a direct comparison, even though, for example, scale scores in both the prior framework and the current one are on the 0 to 300 scale. The comparison is meaningless because you're scoring something completely different. So we would strongly discourage people making comparisons back.
There were significant changes made in the assessment framework, and in the assessment framework that's on the website, you can find on pages 15 and 16 a brief summary of those changes, and that will, I think, be convincing of why you shouldn't really compare the results of the two assessments.
Thank you very much. Our next question comes from Anna Kuchman with Scientific American. She'd like to know if we can comment on the relationship between standards and achievement. Nebraska, Idaho, and Montana's science standards earned Fs from the Thomas B. Fordham Foundation this year, but they did better than average on this. Is there any discernment or feedback that can be offered to her on how to make sense of that difference?
So, you may know that every 2 years we release, for reading and mathematics, NCS releases a report on trying to map the relative stringency of state standards onto NAEP scale so that you can compare states against each other. Our methods are quite different than what Fordham uses. Again, we look at the data from state assessments and from NAEP and try and do this statistically. Fordham generally has assembled a panel of judges to try and rate the content of the standards. As you asked, they provide letter grades. I'm not sure about the sort of, I can't speak to the quality of how that works, although I'm sure that Fordham does spend a great deal of time on that. But we get this question all the time with reading and math, and I'll tell you, it's very difficult to answer. I mean, what you see is that states make changes to their standards for very different reasons, and some states may have quite rigorous or stringent standards in some subjects because they're maybe trying to pull their students ahead or setting a high bar for other reasons. But other states have found, by whatever chance, that their standards may be too high or too low for what they're intending to instruct, and then they will actually shift them one way or the other. And we see certain evidence of that shifting over time. I should point out another report, though, on this subject that's a bit more technical and follows more of our methodology. The advocacy group changed the equation. The Science Advocacy Group actually used a similar mapping methodology with the 2009 science results to what we do at NCS, and they actually are able to use that to rank states against each other in terms of the relative proficiency of their cut scores in science on their state assessments for those states that have them. And so I would strongly encourage you to take a look at that in addition to the Fordham report before maybe reaching conclusions about how relatively stringent or of high quality the different state standards are.
I wanted to add to what Jack had said, too, and just caution the questioner that just because the standards are high or rigorous doesn't mean they're actually, the content of them is actually being implemented with fidelity in the classroom. And the procedure that Jack is talking about looks at their proficiency expectation standard rather than the substantive content of the standards and how it's being taught. So this is a complicated issue. How students achieve will depend on what was their starting point, not just did they add on new standards. So if the students were already achieving high, they may continue to achieve high. So I think this is a very complex issue, and I just caution the listener to be careful in making these interpretations.
And I would add that for the 2011 data this data that we're looking at today, we're actually going to add our mapping a report, the science data for grade 8. And so we're going to have a chance to examine not just reading and math standards, the mapping of their standards using NAEP as a common index, but also the science. So stay tuned for that report. We anticipate within the next 12 months to have that available for the public.
Great, thank you all. Our next question is from William Bertrand. He would like to know if there are plans on developing a STEM NAEP, or will there be a way of using the results from math, science, and technology and engineering to make a determination of how STEM is being taught and understood? Cornelia?
He's really ahead of us and challenging us, isn't he? I think it's very interesting. We do feel good about having TEL being added to our complement of assessments in science and math, but I don't think we yet know how successful TEL will be. You heard Dr. Carr speak earlier about pilot testing going on next year and then a probe in 2014. So I think we're not going to make promises that we can't keep at this time.
Yeah, I would just say, I don't see where a, quote, STEM NAEP would be necessary if we have coverage in mathematics and science, and if we're successful in measuring technology and engineering literacy. I think we will have covered the breadth of topics probably much more deeply than we could if we tried to assemble them all in a single assessment.
Great, thank you. And unfortunately, we have time for just one more question. Again, as a reminder, if we were not able to respond during this event, we will do so via email. And our final question comes from Sarah Pedamonte, and she'd like to know if teachers described the nature of the hands-on activities that were used. Jack, could you answer that for us?
Yes, actually. So we asked teachers to describe what extent did their students do hands-on tasks, specifically either using chemicals, so like a chemistry task, using electricity, using living things, so a biology task, for example, like our mosquito example, or perhaps with frogs or formerly living things. And then also in the earth and space sciences, whether or not they used hands-on tasks that involved rocks and minerals. And so you can look online on the NAEP Data Explorer and actually disaggregate by those various tasks. So just to give you a quick example, so with rocks and minerals, 43% of 8th grade teachers said that they used a hands-on task during that year of instruction involving rocks and minerals, compared to 57% who did not. And using another example of a thermometer or a barometer, 58% used a hands-on science task for instruction that used a thermometer or barometer.
Great. Thank you so much. That concludes our Q&A.
Thank you, Amy, and thanks to all of you who engaged in our question and answer period today. We appreciate all of your thought-provoking questions. Before we end today's webinar, allow me to offer just a few other closing comments. I would like you to visit the Governing Board site for the speakers' comments and other additional science materials that we prepared for this release. There are also links to the Nation's Report Card website that you heard Jack and Peggy talk about, where the NAEP Data Explorer and the release questions are found. I mentioned earlier the release next month of the test, the assessment, and the reporting of the hands-on tasks and interactive computer tasks. This is going to be an online release, so I think you'll find that very interesting, and we'll let you know more about that. To really get up-to-date information, you can follow us on Facebook and Twitter. In closing, I would like to thank Jack, Hector, and Jennifer for being with us today and answering your questions and providing their insightful comments. And of course, we thank all of you who participated. I hope you have a great sunny day today.